This is where we left the model last week, and what I was going to do next was turn the mouse on. Right, at the moment on our shaft we have a slot cut here for the tab washer, and then we have a couple of diameters here and then a slot for the keyway. And we need to seal this area, so we need the shaft to be able to rotate but still be sealed. Now the trouble with the slot is that it reduces the diameter available that you can use to seal on. So you don't get a very adequate shoulder to butt the drive hub up against. So the way we can overcome that problem is to put a collar on the shaft, which we seal to the shaft and provides a bigger diameter and can butt up against the end of the thread. So you get back that sort of reduced diameter caused by the keyway. So that's basically it. So what we have to do is we had our diameter for the lock nut, and we have our diameter for the shaft where the keyway is. You get all of that from your design calculations. The diameter here in between needs to be slightly bigger than this and needs to be suitable for an O-ring to go up against. So if I open up, this is a table of O-ring sizes, and our situation is that we're going to put the O-ring onto the outside diameter of a shaft. So we just look down here for a suitable size. Let's see, what is it at the moment? If I measure that, take that diameter there. So the diameter there is 36. So if you use a 2.4 cross-section O-ring, this is in the tables in your notes, it's on page 6.14. So 2.4 cross-section, and we're looking for a diameter of around 35, 36. Well, there happens to be one at 36, so that's fine, we'll use that. If you can't get one that suits you exactly, don't worry too much. I mean, they are elastomeric at the end of the day, so you can stretch them slightly. If possible, use a standard size, but if not, you just have to stretch it a tiny bit, that's okay. So we're going to put a collar on the shaft, and we need to put a slot inside the collar for the O-ring to fit, and the dimensions for that are given here. It has a width of 3.1 millimeters and a radial depth of between 1.97 and 1.84. So let's have a look. I think I've got a model here open already of a collar. So there you go, it's just a simple rectangular shape. The internal diameter is 36, and then I have my groove in the middle, 3.1 wide by 1.9 radial depth. And you need some material around it to form the outside diameter of the collar. And what you have to do is choose a size that will match a typical radial lip seal, like we did the other week. We created a radial lip seal. So if I have a look in the tables there, I've got it as 50 at the moment, and I think 50 is probably quite a good size. You want a sensible amount of thickness without it being mad. So here was our table for seal sizes. This is lip seal sizes. That's on page 8.10. And I have a choice of 45 or 50, basically, or 55. Well, I think 50 looked okay. And I'm going to have to choose a seal to go onto a 50 diameter. So we'll make that, say, this one in the middle, 72 by 8. So that will be my seal. Length of it is 8. I'll make the collar about twice the thickness of the seal. You can make it, doesn't matter too much. So what have we got here? So 16 long, simple rectangular shape, and we create the basic outline. Now what I should do here, I'll just wind back this feature tree here. up. So there's my basic shape with the groove inside. And then we add on the chamfers on the two ends, and you get the dimensions from the chamfers again from the tables here. So there was the basic seal sizes, and these are the dimensions on page, what would that be, 12, give the dimensions for the lead on for the seal. So you'll see here that it's saying that for a 50 diameter I need, it says minus 3.5 to give this diameter, so that's a radial depth of 1.75 and an angle of between 15 and 30, so we'll say that it's 20. So if I have a look at the model here, the chamfer details, if I do look at that, it's got a 1.75 radial depth, and you have to put in the complementary angle in this instance, so it's 70 rather than 20, and that produces one chamfer, and then of course you have to do the other one, like so, and you can also put a little small chamfer on those corners in there, and finally you can round these corners as it suggests that you do in the notes. So that's the collar. Right, let's put that on the shaft. So we'll do assembly, insert component, rails, and I'll call it collar. Just dump it over there, and we'll have to turn on and off the section. And to get that mated, what we'll do is we'll just do the end face here up against the shoulder on the shaft. So that's got that one. And then the internal diameter here with this diameter here. Okay? And if I turn on and off my my section now, we'll get that sectioned as well. Now, you'll see here there's a space for the O-ring, and we'll do that probably next week, the O-ring. I want to get the main things done today. Also on the shaft, you should have a little lead on the shaft so that the O-ring doesn't get nicked when you assemble it. Okay? But basically that's what I want to do. So the problem I have now is that I need my seal to run on the outside diameter of this collar, and there isn't anything here that I can put the seal into. So what we're going to have to do is create a housing to carry the seal, and I'm going to start that off today. I don't know if I'll finish it. What I'm going to do to line it up is I'm going to use this diameter here, so we'll just check to make sure we know what size that is. So evaluate, measure, and that diameter there, and that's 82 diameter. Okay? So we'll create a seal housing. And so new part. I think this is shown in your sketches, but well, we'll have a go anyway. So sketch, front plane, we'll put on an axis to start with. And then we'll start to draw in a basic shape. So I have no idea what I'm doing here, by the way, but we'll have a go at it anyway. So actually, I am lying. I do have an idea what I'm doing, but I'm just going to generate a shape that is going to look a bit random to start with. It is essentially going to have the components that I need. Okay, so this little bit here, this is going to be a revolved part. This little bit here is going to be the spigot that goes into that recess in the case, and this bit here is going to be the bit that carries the seal. Okay, so we need to put on some dimensions. The first thing I'm going to do is put on an alignment to align this point here with this point here, that way we'll have a starting point. So, we'll put on this diameter here, I suppose, is the first thing to go on, because we know that dimension, I just measured it. That was going to be 82. Okay. Now, the length of that spigot, I'm going to have a chamfer on the end of here, and there'll be a chamfer on the end of the case. So each of those is going to be 1 millimetre, so that's 2 millimetres gone. So I need at least another 2 millimetres of length to allow an adequate spigot. So we'll put on that as a dimension. So we'll put that on as 4. So 2 plus 2 is 4. What else can we do? I suppose the thickness of this spigot we could set at this point. It doesn't need to be very much. I'm going to put on 3 there. That will be adequate for that. Let's put on a diameter for this, because this is going to be the diameter of the seal. Okay, so axis up to here. And if you remember, when I was selecting the seal, I chose a diameter of 72. So 72. Now that's partially turned this inside out. We'll fix that. What we'll do is we turn that off, and we just grab this line here and move it up there. Until it has a dimension on it, it's not going to move the way we want it to. Okay, so I think that was right, wasn't it? 72? 50, 72, yep. Okay. Right, now, this little bit here is providing a shoulder for the seal to press up against. So that only needs to have a radial depth of about 2. When you put things on sketches, you don't always dimension it the way you would on a part drawing. I mean, this would be considered bad practice, dimensioning things as radial depths. But on a sketch, it's very useful, because it means if I change that diameter, that will move with it. Okay. Right, this is going to be a flange, so I think 6 millimetres thick for that will do nicely. So 6. Right, what else? I'll zoom in here a little bit. Okay. I suppose we should put on a dimension from here up to here, which is where the seal will be, because that's going to be the thing we use to position things. So I just have to totally guess at the moment, okay? So I don't know. I'm going to put in 17. I have no idea whether that's right. Let's turn that inside out. Drag that over there, and to stop it turning inside out again, I'll put on a dimension from here to here, and it can be quite thin, this bit. 2 millimetres will do nicely. I suppose I could put on a dimension from this line to this point. Now you have to dimension to a point because it's over at an angle, and that can be quite small as well, I think. So 2, and I'll then set on an angle on here. I've nearly got everything pinned down now, so an angle from here onto here, I suppose, will do nicely. And I don't know, let's try 20, see what that looks like. Yeah, might even get away with 15. You'll see what that's about in a while. The only thing I haven't pinned down is this diameter here. Quite honestly, it doesn't actually matter because we're going to trim the outside, but I'll put on a dimension anyway just so that I can say everything is constrained. So we'll go up to there, and I don't know, 150. It's just a big diameter basically. I can see a dimension that's not set. I haven't positioned this end point. Well, my seal was 8 thick, and if I look in the notes, it says that for an 8mm seal, right, B2 needs to be 8.3. I'm going to make it 8.5, so it's slightly longer than it needs to be. So we'll just dimension armour here. Whoops. Okay. So that's everything dimensioned there. Right. So we'll exit that. And I've left that selected, so if I do revolved feature, it will instantly produce that part. And we can now put this into the assembly and see whether it's anything close to being the right sort of size and shape. So we'll save that file, save, and we'll call that housing seal. Then I can shut that down, and then we can install it in our model. So, assembly, insert component, browse, housing seal, there it is. Drop that over there. I have to turn the section on and off as usual. Okay, now, what we'll do is we'll make this face level with this one. So mate this face here and this face there, and it's done it the right way around, so that's good. So we like that, and then we get the spigot here, and we align that up with that diameter there. Okay, now I'm going to turn my section on and off again. Now there will be more constraints that have to come in yet, but we'll not worry about those for the moment. Okay, now then, what I wanted to see, and we'll true this up, is I wanted to see where the seal will end up. And at the moment the seal is going to end up in the wrong place, okay? So I need this to move over by a reasonable margin. And I think possibly the easiest way to do that is to edit it in place. So if we do edit part, and it's basically this sketch here we need to edit. Okay, so we'll be able to see what happens. So this dimension here is the key one. And essentially, we'll just bring it over until the seal would run roughly in the middle of this thing. So you'll see it's fairly much going to run in the middle. It could go 10 or 11, probably at work. I'll tell you what, I'll make it 11, so I'm going to push it out slightly because the seal is actually over to one side anyway. Okay, so we've got that. Right then, so finish that. And finish that. So that's down in the right sort of place. There are all sorts of chamfers and all sorts of things to go on this yet. But what I'm going to do is I'm going to assemble my seal. And I've already created a seal, so we'll put that in. So browse, seals. There it is, 50 by 72 by 8. Just put that down there. On and off with a section. Now, the first thing to do will be to get this end face butted up onto this lip here. So you have to zoom in right in for this because there's so little surface to actually see. Actually, I'll say catch that, I think, so maybe I don't. So we'll do that. And mate, not been quite so helpful when so we're zooming on this. Okay, so the lip of the seal is running on the outside diameter there. You can see now that if you put a drive hub on here, that's going to butt up against that collar. Let me just zoom in right into this detail here. Now, there's a couple of things you need to note about this collar. It must protrude beyond the end of the step on the shaft, because otherwise when you put on a drive hub there's a danger that it won't clamp up against the collar. So you want the collar to be trapped by whatever drive hub you're putting on. So the end of the shaft here where the shoulder is must be inside the line of that. And the other thing is that the end of this collar must be outside the line of the seal housing, because otherwise there's a danger that when you clamp on a drive hub you end up clamping up against the seal housing. So we will have to put a lead on here and we will have to put an O-ring in here, but for the moment I want to move on to some other things. Okay, right, well, that was quite good, so we'll just save that just so we've backed it up. Right then, the next thing I want to do is, and I'm sort of going to ignore this thing, in fact, just to make life easy, I'm going to actually hide it. Housing seal, just hide component. It's going to sort of get in the way a little bit for the next step. The gearbox that you looked at in the artifact study had a ring going around the outside of the output shaft to enable you to mount the thing. So I thought we would do something similar. So that's what I'm going to do next. So we'll open up this case. So I'm going to be working quite a lot on the output case here. Right, so we have to go back up the top and we'll open that up. Okay, so we're going to put a ring going around this, and it doesn't really matter too much what surface you select. I'll probably do it off this reference surface. So let's have a look. Feature, extruded base, extruded boss, sorry. And we'll select our reference plane, so front plane there. And I'm just going to draw a circle basically. Well, what I'll do is I'll go plane on so I can see what I'm doing. Okay, I want to see the outside of the case, and all I'm going to do is draw a big circle. So it's going to be outside of that ring of bosses, and this will vary so much depending on how much space you've got. So, and sometimes it forces you into making all sorts of changes, but anyway. We're just sticking a size at the moment, I don't know. There's two ways of doing this. Either you can make sure, this is the inside diameter I'm doing here, either you can make sure that this has an adequate gap at the bottom for putting in fillets around these bosses, or you can put it in tight and then you have to do a face fillet between the two surfaces. Now I don't think I've got room to push this ring as far out as I'd like to, so I will have to put in a face fillet, so that's what I'm going to do. So we'll put in a value, I don't know, let's try 145, I think, 145. Okay, and I'm then going to do an offset from this of, let's say 10. Actually 9 will be enough. Okay, so that's offset that. And by doing an offset, it means if I change this diameter, the two rings will move together. So that's why I've used an offset rather than a diameter. So I need to get bosses in outside of this, so that's why I'm looking at this basic shape now to see if I think I've got room, and I think I have. So I'm happy enough to leave it like that. So what we've got to do now is protrude this. Okay, now I started off by drawing this on this plane here. It's clearly not where I want, so we're going to do an offset plane, And essentially what I'm going to do is offset it, it's going the wrong way there, offset it so it goes right outside of this thing. I say right outside. What I need, it's going to be around there, okay? So let's screw this up and we can have a look at this. It has to be higher than these two bosses here, okay? You need to have probably around 6mm or so higher than those bosses, and ideally it should be less than the height of this boss. I say ideally, you can certainly have it level if that's necessary, and I have on occasion seen it where people have actually done it that this one is inside, slightly lower down, but I wasn't planning to show that. So let's have a look. Let's make it 90 as a nice round number. So that's got that there. Then I want to extrude this inwards as a up to body. So we'll select this body, and at the moment it's trying to do it outwards. We need to change the direction. So there's the ring coming in there that we're going to have on this, and I've done it by protruding outwards going in because of the sort of curvature of the edge of the case. If I'd taken it from this surface and gone outwards, I would have ended up with a tiny little gap under here where the corners are rounded off. By doing it as a protrusion going inwards, you'll see this is a principle I use all the time. It always fills in those little gaps and makes a much better model. Okay, you're taking a real big risk if you take that surface and come outwards. Well, the other thing is you'll end up probably with some of this boss protruding inside your bearing boss. So, right, so that's the basic shape. Now I do want some draft on it. So I want a 3 draft, and looking at that, it's a lot narrower at the bottom than it is at the top, so it's clearly the wrong way. So we'll click that to draft outwards. And yeah, that looks alright. So we'll do that. Okay, so that's got my basic ring mounted on there. Okay, now then, if we're going to bolt this to something, we're going to need some bosses. So what we should do is we'll do extruded boss, and I'm going to select this surface because it's basically going to be level with it, and like so, and we'll just zoom in here, and I want to use M10 bolts to bolt this to whatever else it's going to be bolted to, so a little bit heavier than the bolts holding the thing together. So I use my rule of thumb of doubling the diameter and adding on 2, so that will make that 22 diameter. So we'll just draw on a circle here, and I'm just guessing totally where that is at the moment. Right, the first thing is I need to make it level with the axis, so add relationship, so there onto there, and make that horizontally aligned. I said I wanted 22 diameter, so we'll put on here 22. Now, this is the ring here, and I need this to be positioned a little way out from here, so let me just grab that for the moment and just drag it if I can. Yeah. No, I'll have to do it with dimensions. Okay, let's put on a dimension from the centre of this to this ring here. And it's gone to the centre, I don't mind that. That's what it does by default. You have to sort of enter it, and then you can edit it by changing the leaders. Change that to minimum, and now it dimensions from that edge there. Okay, you have to do that, and then you can edit it. So, let's see. We'll start off with 5, and then we'll increment it. So, now I need the boss to be reasonably. If you can imagine, I'm going to put a spigot on this thing, and I want the full circle to be outside of the spigot. And the spigot is going to take 2 or 3 millimetres here, so I want this to be well outside of the ring. Okay? And then what I'm going to do is put on a little straight bit here so that it doesn't end up being undercut. Okay, so we'll do that. And we'll just click on there to get a tangential line. Make sure it's horizontal. Drop that down to there. And I don't know if you can see a little blue chain dot line that's lined up at the bottom edge, so that's what I wanted. And then that onto there like so. And what we'll have to do is put on a dimension from the centre of this to there. And we'll make that 12, say. And then I'll trim out the bit of the circle I don't want. And it's left that line as blue, and I know why. If you look, this has a horizontal alignment on it, and this has a vertical. That one, somehow I managed to miss getting a horizontal alignment, so we'll have to add in a relationship there, so they're horizontal, and I should be happy now. Okay, so that's got me my sort of D-shaped boss, and there should be plenty of room for getting a fastener in there and so forth. Okay, so we close the sketch, and now we want to do up to body. Here's the body here, and we want to add on some draft, so put on a draft there, that's gone inwards, we need to draft outwards. So that's got that on there, and it's actually run over the edge here totally, but it seems to be working, so. Okay, so that's got on one boss. Right, have enough of that. Now, what I'm going to do is see if I can get on the other bosses. And to do that, I'm going to use a pattern. So, what we should do is circular pattern. Now it knows that that's the feature that I want to use, and what it's looking for now is something to rotate this about. Now it looks usually for an axis, but it will also take a diameter. So if I select this bore here, it will select that. I want 6 bosses, so that works pretty well. So we'll do that, and there you go, it's got 6 bosses on. And they all seem to fit on there quite nicely. Okay, let me just zoom out slightly here and then back in. It's just a little area here you need to look out for. On my particular one, the bosses just overlap that, and that's brilliant. That makes my life very easy. If you get a thin gap in there, you'll have to fill in that gap. And you can do it by using face fillets, or you can just put in a block of material before you cut out the bore on the other side. So for me it's worked very nicely, so I'm happy enough with that. Right then, so the next step. The difficult bit with all of this is filleting and putting on draft. Now, that mounting ring has draft, this has draft. I put draft on these bosses earlier, so I'm happy enough with that. The first thing I'm going to do is I'm going to round my external corners. So, fillet, put on a 2mm radius, constant radius. So it's anything on here that's an external corner, so like that, like that. These bosses here are going to be left cast, so the ends of those can be round as well, like that. Now, have to watch out, this goes around inside here, so I need to put that on there like that. Okay. And because of putting in the face fillet, I'm going to put a radius on this corner here, because that will make sure that I can get the face fillet in. You remember, if you have a sharp corner, the face fillet comes up, sees the sharp corner, it doesn't know where to go. If you put on a radius, it can roll around. So, that's got that done. do the face fillets next actually. And in fact, I'm not sure if I need a face fillet on there or not, but we'll do these ones on these boxes anyway. So, fillet, face fillet, 5, and we select, say, that, and we have to select that, and then that, and that's gone in there, and if I just zoom in on that, you see why I rounded that top corner? It's just rolling onto it. If I'd had a sharp corner there, it wouldn't have allowed that fillet to go around. Okay, so that's why you round it off. Sometimes you can get away with it. If the fillet's not going to extend the whole way up, you'll get away with it. But because mine does, you need to have that in. Okay, let's do the other ones. So, fillet, face fillet, so that surface there, that surface, ring, that's there, so that's good. Fillet, and finally, okay, so it's got all of those in there. Now, I think I'm probably going to need one in there as well. It does look rather close together, so we'll do that. Fillet, face fillet, this surface here, this surface here. Yep, certainly did need one in there. Okay. Right, I'm now going to put in the fillets that are sort of perpendicular to the gasket face. Okay, so it's all these ones that go this way. The order in which you put in the fillets is terribly important. So it's very hard to explain what the actual logic is. I just find it naturally. It just comes to me, but more or less you do it in the order I'm saying. So let's have a look. Fillets, there's a lot of fillets that go in here. We'll put in these two little ones in here. Oh, wait a moment. Constant radius. And we'll put in here and here. Okay, and then we go around doing all of these. So that's all those on the outside there. I haven't done here, and you'll see why in a little bit. I can do these ones inside as well. So we'll do and if you forget one, you can always come back and add it. Just open up the feature and stick it in again. So that's got all of those in there. Okay, so we'll do that. And I said to you I hadn't actually added in the one on this corner here, and you'll see why now. You needed this other one to let this flow around. So if we select this now and put that in, you see how that flows right the way around and over the other side. But it won't do that until it has that vertical fillet in first. And it's a similar story in here. As you put one in and it will flow around, so one in there. So we've got those two. Now I think that's got everything that sort of is roughly perpendicular to the gasket face. So we could put in these other fillets. I'll tell you what I will do though. I'll put in a fillet on this lip here first, a couple of fillets And to do that, I want to wind back before this boss. So where's that boss? That's up there. So boss 4 will we'll just wind our feature tree back here. Let's have a look. That will do. I just want it before before any features actually start running over it. So there's 2 radii to put on here. There's, I suppose I'll better zoom in here so you can see it clearly. If we just zoom in at the top there. Right, there's the external corner, and as a rule of thumb I'm using 2 for all my external corners. So constant radius, so that will run the whole way around the case. If we just put that on there. Okay, and then there's my internal corner. Now I will select that corner, but it will actually run over onto that radii there. That's why I have to put on that first. So 5 for that. Select that corner there. Okay, and you see the way that that is running onto that fillet. Okay, so we can now wind our feature tree back down to where it was. Okay, now then, I don't know why, but this next bit gives me a certain amount of satisfaction. I'm going to put a fillet. I don't know what you've read into that comment, really. Right. Okay, constant radius fillet, and I'm going to select this point here, and you see what happens. If you've done everything right, that's what happens. You get a fillet that runs the whole way around everywhere. And I don't know, as I say, I just think that's great. We can also put fillets into here. So now I wasn't sure whether this was going to go in here or not. If it hadn't, I would have had to put in a face fillet first. So yours may be different. Okay. See all that nicely blended in there. It's just occurred to me I've missed off a couple of other fillets. Let me edit that to add those in. Doesn't have to be, but I'm just going to do that anyway. These 2 bosses,